Video number 135, solving linear equations. In this problem, as we can see, we're going to be using the distributive property, and a very common mistake, and I want to make sure everybody's aware of this. You see, this is 10 minus 3 times quantity 2x plus 5 equals 15 minus x. What a lot of students will do is they'll distribute the 3, and they'll call this 6x. Then they'll distribute the 3 here, they'll call it 15. Now, a lot of students will they'll bring this minus sign down, and then they bring the plus sign down. That is a big mistake. What you need to do is distribute the negative 3 to call this negative 6x. Okay. Then distribute the negative 3 here to call this a minus 15 in the middle. Then there's no sign to bring down, so you just put a plus sign in front. So you'd end up with a 10, a negative 6x, a negative 15. And if you want, you could put a plus sign right in front of here. Either way, you're going to add this together to get a negative 5. Okay, that's on they're both on the left side, so that's why you combine them together. We're going to move the 6x over here to make it positive 5x. Move the 15 over here to make it negative 20. Divide, and you get negative 4. Okay, so this would be solving a linear equation that has a distributive property involved. Next one, solving a linear equation that's got fractions. What we do with the equations is we take advantage of the one simple rule in mathematics. There's one rule, and here's how it goes. The rule is, okay, I'm sorry, the rule for solving equations is to stay balanced. That's the only rule. So, for example, x plus 1 equals 11. Everybody knows the answer is 10. And someone might say, well, you have to subtract 1 on both sides. You do not have to do anything. You can do minus 3 on both sides. And you get what? X minus 2 is 8. Well, guess what the answer is? It's still 10. X is still 10 no matter what you do, as long as you stay balanced. What about this? What if you multiply everything by 3? You'll have 3x minus 6 equals 24. Isn't the answer still 10? Yes, it is. 3 times 10 minus 6 is 24. Now, just one point something out here real quick. I always introduce this to my students every year, is that whenever you're adding or subtracting on both sides, you only do minus 3 to one number here and one number over there. You do it to one term on each side. When multiplying the left side and the right side, you multiply by all 3 terms in order to stay balanced. Just to point that out, there is a slight difference there. Okay. In this equation, we have 4 terms, 1, 2, 3, 4, and we're going to multiply everything by a 6. And the reason is because 6 over 3 is 2, that gets rid of the fraction, and 6 over 6 is 1. So we're going to multiply all 4 terms by 6. So 6 times 4 thirds, 6 times 8, 6 times 5, 6, 6 times 10. That puts us here. Now there's a couple ways to get to this step. What you could do is you could put this over 1 and do 24 divided by 3 is 8. Another way is this. This is so much easier. 6 over 3 is how much? 2. 2 times 4, 8. Okay? Now this next one here is 48. Do not forget to multiply the 6 times the 8. You got to stay balanced by multiplying all the terms. Okay? Then we're going to multiply 6 times 5, 6. Again, you could do 30 over 6, which is 5, but it's easier just to do 1 times 5, 5x. Okay? 60 over 3 is 20, or what? 2 times 20. I'm sorry, 2 times 10, 20. Alright? It's just easier that way to divide first, then multiply. So again, that was 2 times 4, 1 times 5, 2 times 10. And this was just 48. Alright? Then at this point, you're just going to go ahead and move the 5x over, move the 48 over. You're going to move the 5x over by subtracting 5x on both sides. You do not have to write this down every time. Just minus 5x is going to be 3x. And that's right here. So minus 5x gives you 3x on the left, and then minus 48 gives you negative 68. If you divide this out, you get negative 68 over 3, which is negative 22 and 2/3. All right? So this would be an equation where you solve one that's got a fraction. Here's another one with a fraction, except this time you got the distributive property involved. So what we would do here, the best way to do this, probably the most efficient way, would be to go ahead and distribute the 1/15 first. 1/15 will give you 2/15 x minus 7/15. All right. Then I also went ahead and dispersed the 9 into both numbers, just to make sure you're okay with this. Think about this. 12 plus 8 over 4. Does everybody agree? The answer is what? 5, because you'll have 20 over 4, right? You could look at this as being 20 over 4, which is 5. Another way to do this is to throw the 4 into each number. That'll give you 12 over 4 plus 8 over 4. What's that? 3 plus 2, which is 5, of course. So we've just shown that you can solve this problem here by adding together, then dividing, or you can divide the 4 into each one. Now in this case, we're not really allowed to add x and 5 together. That's why we divide the 9 into each one. Okay, so you got x over 9, 5 over 9. Then this step here, this problem, is just like the last one. In fact, it's arguably easier than this because you're actually going to multiply all 4 terms and use the fraction on all of them. You're not going to have to worry about remembering to do a 48 for this one, which is what we did for this one here. Now, we want to multiply by the lowest common multiple. The lowest that they have in common as far as the multiples are concerned. We want a multiple of 9 and a multiple of 15 so that when we multiply everything, the denominators will cancel out. That's why we chose 6. If you notice, 6 was a multiple of 6. 6 is a multiple of 3. And it just cancels out those denominators. So that's why we do the same thing here. We're going to multiply by 45 as the lowest common multiple. Now, one of the ways to figure that out for some of the novices, people that are perhaps this was glossed over because the world of calculators, some of the teachers have gotten lazy over the years. But here's your 9 and 15. 15, 30, 45, 60, and all that stuff. All right, 9, 18, 27, 36, 45, 54. Now, what you do is the lowest that they have in common. Now, actually, I wouldn't even have listed the 9. Just take the larger of the two denominators and list those multiples. Start with 15. Does 15 divide by 9? No. Does 30 divide by 9? No. Does 45? Yes. Guess what that is? That's the lowest common multiple. You don't need to list both. Just take the higher number, list the multiples, and then test that one. Does that divide by 9? No. Does that divide by 9? No. Oh, yes. Therefore, that's the lowest. If you start from the lowest, that's the lowest that they have in common. Lowest common multiple. Now, we're going to go ahead and multiply. Now, watch this. I'm going to show you how to go this. This is easier. Take the 45. Remember to divide first. 45 divided by 15 is how much? 3 times 2, 6x. See that? 45 divided by 15 is 3 times 2, 6. Watch the next one. 45 divided by 15 is 3 times 7, 21. 45 divided by 9, 5 times x, 5x. 45 divided by 9 is 5. 5 times 5, 25. Whew. So much easier to do it this way. Then you go ahead and combine like terms. Move the 5x over, you get a 1x. Move the 21 over, you get a 46. And bam! You're all set. Alright, next one. Oh, here we go. What about when there's decimals? Don't get scared. You can do the same thing. Remember, solving equations, you only have one rule. Stay balanced. Do whatever you want, just stay balanced. So in this one, we're going to multiply everything by 100. Bam! 0.7 times 100 is 70. 0.08 times 100 is 8. 0.5 times 100 is 50. 0.42 times 100 is 42. Now again, 100 is nothing more than moving a decimal over 2 places. Okay, so you move that over twice, twice, twice. Alright, so just move the decimal over 2 places, that's all you're doing. Now this becomes a 20. When you subtract, that becomes a negative 50, divide negative 5 halves. Now again, for those of us that you know, are rather maybe novices, but 5.23 times 10, okay, if you did the old school way of multiplying this, all right, well, actually, you wouldn't even do this one this way. You would do 5.23 times 10. Well, look what happens. You bring down the 0, and then you do 3, 2, 5. And then what happens is this. You then say, okay, well, the answer then goes as a 52.3. Why is that? Because... Why is that here? What am I doing wrong here? You see, you wouldn't even do this problem this way. But you would get 52.3. If you actually, you know what we'll do? Let's do it this way. Let's do the old school way here. I know I'm doing something wrong here. Okay, 5.23. Let's go 0, 0, 0. Oh, that's why, because you hold a 0 here, so you get 3, 2, and 5. Add that up, 0, 3, 2, 5. Put the decimal here. Alright, so that's how that all works out. Okay, so the pattern is however many zeros you do, you move that decimal over to the right. Okay, next one. Here's an interesting case here. Here's an interesting case. We have negative 4 plus 11 equals 10 minus 2 times 2x minus a half. What you'll do is distribute the negative 2. Distribute the negative 2. That'll be a negative 4x and a what? Plus 1. Okay, now you got a negative 4x here. We're going to add the 10 and 11, 10 and 1 together, get 11. Now look what happens here. This is called an identity equation because it has the same values on each side. So x could be any real number to satisfy the equation, therefore x is all real numbers. Think about it. What if x was 10? Wouldn't you get a correct answer? Yeah, you get negative 40 plus 11 on both sides. All right, you get 11 minus 40. That's going to be whatever that is. That's going to be negative 29 or whatever. Okay. What if x is 1? Well, you'll get 7. You'll get 7. So therefore, x could be anything. That's why we say x is all real numbers. You'll also see it written this way with a capital R. Okay, with these two lines there means all real numbers. All right. You'll also see in what's it called? Interval notation. All real numbers means negative infinity to positive infinity. Means any number between negative infinity and positive infinity. That means all real numbers, obviously, also. And this is a special case number 2. We'll go ahead and distribute the 4, and then we got 8x and 12. We'll put the 8x and x together. You get 7x. Look what happens. The 7x's are going to cancel out. You end up with 8 equals negative 12. Well, this is a false statement. See, the x's cancel. You get 8 equals negative 12. This is false. Therefore, there's no solution for x. So we would say that x is the empty set. Another way to say this would be x equals this symbol here. Okay. Now, one thing we would not do, you will not put down x equals and then put the set symbol with the empty set symbol. This means that x equals the empty set symbol. So make sure it's either an empty set, or you could say x has no real solution. Okay? Questions or concerns, send me an email. Good times.